Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on equation reducible to exact equation, so that each and every equation will not be exact. Some equation will not be exact. Considering that not exact, we are going to do some procedure and steps. Considering that procedure, we are going to represent this equation as exact. How? Now let us see. First, represent the given equation, that is solution given y, which is into x plus y plus 1 dx plus x into x plus 3y plus 2 dy equal to 0. Now multiply y, it is x into y plus y square plus y into dx plus x into x, you get x square plus 3xy plus 2x dy equal to 0. After this is of the form m of x comma y dx plus n of x comma y dy equal to 0. Now represent mn, that is m represent xy plus y square plus y, where n represent x square plus 3xy plus 2x. Now I need to differentiate m with respect to y. Similarly, I need to differentiate n with respect to x. First, let us differentiate m, that is dou m by dou y, which is equal to, see, I need to differentiate term by term with respect to y. In this first term, we have x and y. Since I have y, I can differentiate. X remains constant. Differentiation of y is, with respect to y, is 1. Plus, differentiation of y square is 2y plus differentiation of y is 1, where dou m by dou y, which is equal to x plus 2y plus 1. This is our dou m by dou y. Similarly, let us differentiate n with respect to x, that is dou n by dou x, which is equal to differentiation of x square is 2x plus, since we have x term, so 3y remains constant, differentiation of x is 1 plus 2 remains constant, differentiation of x is 1. Differentiate always term by term, okay. Dou n by dou x, which is equal to 2x plus 3y plus 2. Done. We should check dou m by dou y and dou n by dou x. Both are not same. So dou m by dou y is not equal to dou n by dou x. Therefore, the given equation is not exact. Equation is not exact, but I need to reduce this equation into exact form. How? First, subtract dou m by dou y minus dou n by dou x. Subtract dou m by dou y minus dou n by dou x. What is dou m by dou y? We have x plus 2y plus 1 minus 2x plus 3y plus 2, where x plus 2y plus 1 minus 2x minus 3y minus 2, where you get x minus 2x, you get minus x, 2y minus 3y minus y, 1 minus 2 minus 1, where dou m by dou y minus dou n by dou x. If I take minus common, dou m by dou y minus dou n by dou x, which is equal to minus of x plus y plus 1. Now, if you check this equation for which it is nearest, see, it is slightly nearest to for dou m by dou y. So what I'm going to represent near to m. If since it is near to m, now we are going to represent it with respect to the form 1 by m into dou m by dou y minus dou n by dou x, where 1 by m, what does 1 by m represent? 1 by m represent you have xy plus y square plus y into what is dou m by dou y minus dou n by dou x, you have minus of x plus y plus 1. If you check in the denominator, if you check in the denominator, you have y as common. So what I'm going to do, I'm going to take y as common, that is y into x plus y plus 1 into minus x plus y plus 1, where x plus y plus 1, x plus y plus 1 get cancelled. You get the remaining part, that is 1 by m into dou m by dou y minus dou n by dou x, which is equal to minus 1 by y. Since it is of the equation is represented of the form y, so I am going to represent it as g of y, representing this with respect to g of y. After representing g of y, I am going to find the integral factor or integrating factor. That is integral factor is given by e power of integral minus g of y dy, where which is since the equation is defined with respect to y, so I have defined with respect to g of y. E power of minus integral, you have minus 1 by y dy, minus into minus you get plus e power of integral 1 by y dy. Integration of 1 by y is log y, that is e power of log y. Since e and log get cancelled, you get only y, that is integral factor which is equal to y, integral factor which is equal to y. Now what we are going to do, now we are supposed to do integral factor, sorry, integral integral factor into differential equation, integral factor into differential equation means, first let us represent what is our integral factor y, what is our differential equation. This is our differential equation, that is x y plus y square plus y dx plus x square plus 3xy plus 2x into dy equal to 0. Multiply y. Okay, check once again so that it should not be mistake. Okay, now multiply y into xy plus y square plus y into dx. Similarly, multiply for this also, y into x square plus 3xy plus 2x dy equal to 0. If you multiply, you get xy square plus y cube plus y square dx. Similarly, now we have x square y plus 3xy square plus 2xy into dy equal to 0. This is of the form m of x comma y dx plus the another equation is of the form n of x comma y dy equal to 0. After this, repeat the same condition, that is represent m. What is m? M represent x y square plus y cube plus y square Then represent n, that is x square y plus 3xy square plus 2xy. Okay, done. Now differentiate, repeat the condition, differentiate m with respect to y. What happens? That is, dou m by dou y, differentiate term by term. Since I am differentiating y, I have y square, so x remains constant. Differentiation of y square, you get 2y plus differentiation of y cube, you have 3y square plus differentiation of y square, you have 2y, where dou m by dou y, which is equal to 2xy plus 3y square plus 2y. This is our dou m by dou y. Now, similarly, differentiate n with respect to x, where dou n by dou x, which is equal to differentiation of x square, you have 2x, where y remains constant, plus 3y square remains constant, differentiation of x is 1, plus okay, 2y remains constant, differentiation of x with respect to x is 1, where dou n by dou x, which is equal to 2xy plus 3y square plus 2y. If you check these two equations, see 2xy plus 3y square plus 2y, both are same, then we can conclude dou m by dou y is equal to dou n by dou x. If these two are same, then we can conclude that the given equation is now exact. After this, I need to integrate the function. So, integrating integral m dx plus integral n dy equal to c. But while considering n equation, I need to consider without x term, without x term. So what happens? Integral, what is m? We have 2xy plus 3y square. Okay, that is, sorry, that is not m. M is this. Sorry, m is this. That is x y square plus y cube plus y square into dx plus n without x term. See, in the first we have x, I am not supposed to take x, so this becomes 0. In the second term also we have x, so I am not supposed to take 0. In the third term also we have x, so we are not going to take with respect to, so this becomes 0. Where if I integrate term by term, x y square plus integral y cube, okay, let us define with respect to terms, dx plus integral y cube dx plus integral y square dx equal to c, where y square remains constant, integration of x with respect to dx is x square by 2, plus y cube remains constant, integration of 1 with respect to dx is x, plus integration of y square remains constant, integration of 1 with respect to dx is x equal to c, where x square y square divided by 2 plus x y cube plus x y square equal to c. This is the required solution for the given equation. Is the required solution for the given equation. This is the question which is repeatedly asked in VTU main examination. This is how you need to represent the whole solution of the given equation. First you need to represent mn, differentiate m with respect to y, n with respect to x. If it is not exact, then you need to do dou m by dou y minus dou n by dou x. We need to check for which it is nearest. After that, for which it is nearest, I am going to multiply with respect to denominator. Cancel, you are going to get with respect to either x or with respect to y. Find integral factor. After finding integral factor, whatever you get the value, multiply with respect to differential equation. You will get m dx plus n dy. Consider m and differentiate again with respect to y and x. You will get the exact equation. If you get exact equation, go with the integrating factor or integration. After integration, whatever you get the solution, if this is the required solution, if it is correct, then the given equation is also correct. This is how you are going to represent the solution for the VTU main examination. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.